All right. Examples. Having done poorly on their math final exams in June, 6 students repeated the course in summer school, then took another exam in August. If we consider these students representative of all students who might attend this summer school in recent years, do these results provide evidence that the program is worthwhile? So, knowing that we're ultimately going to be looking at change, I would go ahead and find like the difference between them because we're going to end up needing it anyways. So, we're going to do the change for August minus June. So, what's the difference from August to June here? Like, do August minus, yeah. -4.
16. -6. -2. 6.
All right, so that way we have the change already. That's what we would be having to use to actually find a lot of this stuff. But why is a 2-sample t-test not appropriate in this scenario?
Because it's like
Independent.
Why?
because it's like for the same person.
Yep. It's a before and after, so we need to consider them as a pair. So the students are the same ones taking the test in June and in August. So scores won't be independent. This is a before and after. So consider these data paired. And look at the change in scores. So write a 95% confidence interval for the mean difference between June and August. So you're going to need to create a list with these, the differences. Since we've already done it, you don't need to like do each of these in a list, but just the bottom row here that we did the change, you'll need a list for that, and run one variable stats on it.
You said we're doing 2 lists?
No, you just need one with the change. If these were like crazy numbers or something, or there were a lot of them, we wouldn't have done it by hand. But since there's only 6 of them, we just did them by hand. So we'll need the one variable stats on that. So remember that's under stat calc, one variable stats. So the things that I need are like it's dead or
Well,
like
It never warned me that batteries were low, but
like it just won't come on.
yeah.
Okay, you can use mine in a second if you want.
Examine.
So X bar is 5.33. It's repeating. Standard deviation for the sample is what we want, so that's S of X. Is 7.45. That's rounded. All right, so write a 95% confidence interval for this. So degrees of freedom is going to be 5 because I had 6 here. So it's going to be 5.33 plus or minus the T star for 5, which I'll have to find a table. I left the link over there somewhere. Times 7.45 divided by the square root of 6. Let's see. So we're at 95%. So two-tailed end. So 0.0545. 2.571 is that number that's going there. And this is going to end up coming out to give us, just for the sake of time, negative 2.5 to 13.1. What do we notice about this?
It has negative.
That includes negative values.
Negative values, which means that 0 is included, which could be a problem, right? So notice that 0 is in the interval that could be bad. So, oh no. So conditions for inference, I guess we kind of probably should have done this first, but they ask it after, so just do it down here. So the paired data assumption, the scores are paired by student. So before and after. The independence assumption, obviously each student is independent, and 6 students is less than all, so we kind of include in this assumption the 10% condition as well. So I'm going to say slash 10% for when we do this, but 6 students less than 10% of all students. And each student is independent. All right, is this one random?
Well, it's a representative sample.
Yeah. Not necessarily random, but representative sample. Nearly normal condition. If we put those in a list and looked at the histograms, they would be roughly symmetric. So the histogram of the differences. Between June and August. It's roughly symmetric. If you're just so inclined, you can go check that if you don't believe me. Does it look like there's really any outliers? Yeah. A note that I have here says for AP, make sure you do the histogram. So I would, we say that all the time, but actually show it if it's on the exam itself, Paired t-interval for mean of the difference is d bar plus or minus t star n minus 1 times the standard error of d bar, which this is what we already found up there. This is just the t-interval for it. So negative 2.5 to 13.2. That's already what we had found. Just kind of has us doing it again. So interpret your interval in context. Is the program worthwhile?
I have a question. So is it supposed to be 13.1 or 13.2?
Let me check. I don't know. It's written two different ways on my paper. So probably just a rounding thing. $13.1. All right, so interpret your interval in context. Is the program worthwhile?
No.
Why?
It's
Zero.
It's like in the negatives.
Yeah,
It has people doing worse.
because some of it is below 0. So based on my sample, I am 95% confident that the August scores are 2.5 points lower to 13.1 points higher than the June scores. So the program is not worthwhile.
They all still did pretty awful.
Yeah, 0 is in the interval.
Are they on like a 7-point scale? Something?
No matter how you look at it, that's bad.
Right.
Like 74 is the best, I think, and that's not good.
Like what they even teach in
don't even know what math it is.
Maybe it's calculus too.
What if it's like,
Okay, then maybe it's worth it.
what if it's like pre-algebra?
Well, that's sad.
Yeah.
Me too.
Are you excited for the comments on that?
Yeah.
It's a good thing I read what's on your paper and not what's on this paper when I started to read this question.
It's a different question.
Nope. I just made it sound okay for a Christian school.
Oh.
Ads for many products use attractive images to try to attract attention to the product. Do these ads bring people's attention to the item that was being advertised? We want to design an experiment to see if the presence of attractive images in the advertisement affects the people's ability to remember the product. Describe an experimental design that would require a match pairs T procedure to analyze the results. So, any idea where we should start?
I'm not really sure.
Well, I know that
Like with conditions?
I need to pair them.
Right.
Like maybe have like find like a bunch of people and show them two different advertisements, one that doesn't have these attractive images and then another with those, and then see if they remember them sometime later.
Yeah. So randomly split. Volunteers. Whoa. Into two groups. Group 1 is shown ads with attractive content and record the number that they remember. Group 2, or well, oh wait, not group 2 yet. Hold on. After group 1 does that, then show ads without attractive content and see how many they remember. Then with group 2, do it in reverse. Meaning show them the without and then show them with and see what they remember. So basically just flip the scenario around. So basically, if we wanted to see this, kind of how we used to like show like the pairings of stuff with like the branches, we're gonna have the volunteers, and we're gonna split them into two groups randomly. This is group 1, which is ads with attractive content first. Group 2, ads without attractive content first. And then analyze mean difference in number of ads remembered. I guess up here after I had group 2, I should say also to examine the difference. And so this would allow us to use a paired t-test for that. I was like, whoa. So this one is the paired t-test. I guess I should say 4 mean of differences.
No, it's supposed to start happening at 2 o'clock. Yes, and the peak is at 3.
I think it's just you.
18.
I was just joking. What?
318.
I think something's wrong with my eye. It's been weird all, like, I don't know what happened.
What do you mean it's been weird?
No, it feels like something's across it, but, and like pushing it down, but it's not like.
Like, are you seeing things?
No, it just feels like something's back there.
Oh.
But it's like pressure, but it doesn't hurt.
Did you look at the sun for a long time?
No.
Have you tried making your eyes water?
You told her to go
Like-
cry about it.
Well, I mean, sometimes it
Cry about it,
helps.
Emily.
Sometimes that might get stuff out of your eyes.
That's go cry about it.
I don't wanna cry about it.
All right. Part B. This will be the last part for today. Describe an experimental design that would require an independent sample procedure to analyze the results. So with this one, this will be more of what you were saying for the last one. But we're going to randomly split volunteers into 2 groups again. However, this time it's going to be a little different. Group 1 is showing ads with attractive content. And record number of ads remembered. Then with group 2, show ads without attractive content. And record number of ads remembered. Then compare mean number of items remembered by each group. So this one drawn out kind of more as like the little tree thing. It's gonna look very similar. Volunteers, random. So group 1, ads with attractive content. Group 2, ads without attractive content. And then finally we compare the means. Compare mean number of items remembered. And for this would be a 2 sample t-test for means. So that would be
Y'all
the
matched
difference.
today?
Yeah.
Basically every day.
Oh, really?
Yeah.
And except, because for
Friday.
Friday, y'all don't have.
And we were
anything.
supposed to have one on Friday.
Oh,
Ooh, that's the concert.
yeah.
Who were we supposed to play on Friday?
Shores.
Y'all really catching up at this Are you feeling better?
Kind of.
I'm kind of excited for the match today. I'm not really expecting it to win, but
No, you have to.
Has an opportunity.
Who are you playing?
Summit.
Oh, they're very good.
Yeah, I know, that's why I'm not.
But we're gonna be
You
back.
got it.